Good morning. Today we have to see one more topic, vibrations produced in string. Vibrations produced in string. Today we have to see one more topic, that is vibrations produced in string. Now see, consider a long, thin, uniform conducting wire. Consider a long, thin, uniform conducting wire like this, stretched between two fixed rigid support. If this string is plucked at some point, then transverse waves produces in string which travels along string towards support and gets reflected from support like this. When this string plucked at its any point, then transverse waves produces in string which travels along string towards support and gets reflected from support. Suppose these are incident waves, these are reflected waves, then these incident waves and reflected waves interfere with each other and stationary waves produces in string. See once more. Consider a long, thin, uniform wire. Consider a long, thin, uniform wire stretched between two fixed rigid support. When this string is plucked at some point, then transverse waves produces in string which travels along string towards support and gets reflected from support. These incident waves and reflected waves interfere with each other and stationary waves produces in string. If suppose L, that is length of string, small m, that is mass per unit length of string, T, tension given to string. If L, length of string, small m, that is mass per unit length of string, T, tension given to string, then velocity of transverse waves. Velocity of transverse waves V is equal to square root of T divided by m. This is velocity of transverse waves. If suppose n, that is frequency of wave, lambda, that is wavelength of wave, if n, frequency of wave, lambda, wavelength of wave, then velocity of wave, that is v is equal to n lambda. इथं ज्या ट्रान्सवर्स वेव्स तयार होतात त्याची व्हेलॉसिटी असते रूट टी डिवायडेड बाय एम, बट If n frequency of wave, lambda wavelength of wave, then velocity of wave phi is equal to n lambda. Compare these two equations, we get n lambda is equal to root t divided by m, and therefore frequency of vibrating string 1 divided by lambda root t divided by m. Suppose this is equation number 1. Means stretched string vibrate with frequency n is equal to 1 divided by lambda root t divided by m. T tension given to string, m mass per unit length of string. This is an expression for frequency of vibrating string. Now, different modes of vibrations of string. Different modes of vibrations of string. Vibrations of string. Different modes of vibrations of string. This string vibrates with different modes like this. Vibrations of different modes. See here. Different modes of vibrations of string. If string vibrates such that only one loop is formed. If string vibrates such that only one loop is formed is called as first mode of vibration. If string vibrates such that two loops are formed. String vibrates such that two loops are formed, then it is called as second mode of vibration. If string vibrates such that three loops are formed like this, it's called as third mode of vibration. Third mode of vibration. For first mode of vibration, number of loops p is equal to 1. For second mode of vibrations, number of loops p is equal to 2. For third mode of vibrations, number of loops p is equal to 3 like this. String vibrates with different modes of vibrations. First mode of vibration, second mode of vibration, third mode of vibration. Hit a node, hit a node, hit a antinode, hit a node, hit a antinode, hit a node, hit a antinode, hit a node, node, antinode, node, antinode, node, antinode, node. Same. If string vibrates such that only one loop is formed, in which only one antinode and two nodes are formed. एकच अँटीनोड असतो पण नोड मात्र दोन असतात. फॉर फर्स्ट मोड ऑफ व्हायब्रेशन अँटीनोड इज ओनली वन, नोड 2. फॉर सेकंड मोड 2 अँटीनोड 3 nodes. फॉर थर्ड मोड 3 अँटीनोड्स अँड 4 nodes लाईक दिस. म्हणजे जेवढे अँटीनोड असतात त्याच्यापेक्षा नोड एक जास्त असतात. जेवढा मोड तेवढे अँटीनोड आणि त्यापेक्षा एक जास्त नोड्स, या पद्धतीनं. सी डिफरंट मोड्स ऑफ व्हायब्रेशन्स. इफ सपोज L that is length of string. If suppose L that is length of string, then L that is length of string, P that is number of loops. If L length of string, P number of loops, then length of loop म्हणजे हिथून हिथपर्यंतची लेंथ, हिथून हिथपर्यंतची लेंथ म्हणजेच लेंथ ऑफ लूप, हिथून हिथपर्यंतची लेंथ म्हणजेच लेंथ ऑफ लूप. लेंथ ऑफ लूप मीन्स डिस्टन्स बिटवीन टू एंटीनोड्स, डिस्टन्स बिटवीन टू नोड्स. एका लूपची लेंथ, एका लूपची लेंथ म्हणजेच हा नोड आणि हा नोड या दोघांमध्ये डिस्टन्स. लेंथ ऑफ लूप इज नथिंग बट डिस्टन्स बिटवीन टू नोड्स अँड देअरफॉर लेंथ ऑफ लूप म्हणजेच टोटल लेंथ डिवायडेड बाय नंबर ऑफ लूप्स. आता समजा हा लूप आपण घेतला, ह्याची लेंथ किती, तर टोटल लेंथला 3 ने डिवाइड केलं तर एका लूपची लेंथ मिळते. मीन्स लेंथ ऑफ लूप इज इक्वल टू टोटल लेंथ divided by number of loops, that is L divided by P. एका लूपची लेंथ म्हणजेच काय, तर टोटल लेंथ डिवायडेड बाय नंबर ऑफ लूप्स which is equal to distance between two nodes, that is lambda by 2, and therefore lambda is equal to 2L divided by P. This is wavelength of wave. जर लॅम्बडाची व्हॅल्यू 2L बाय पी असेल, लॅम्बडाची व्हॅल्यू 2L बाय पी असेल तर फ्रिक्वेन्सी तयार झाली. मग N इज इक्वल टू 1 डिवाइड बाय 2L बाय पी, त्याचा रेसिप्रोकल केला तर मग P डिवायडेड बाय 2L रूट T डिवायडेड बाय M. सपोज दिस इज इक्वेशन नंबर 2. दिस इज फ्रिक्वेन्सी ऑफ वायब्रेटिंग स्ट्रिंग. Now different modes. First mode of vibration. First mode of vibration. If string vibrates, such that only one loop is formed. Only one loop is formed in which only one antinode and two nodes are produced. Such a mode of vibration is called as first mode of vibration. Only one loop is formed in which one antinode and two nodes are formed. Means number of loops P is equal to 1. If string vibrates such that only one loop is formed is called as first mode of vibration, and therefore frequency of first mode of vibration N1 is equal to value of P1 divided by 2L root T divided by M. Value of P1, therefore frequency N1 is equal to 1 by 2L root T divided by M. This is called as fundamental frequency or first harmonic. This frequency is called as fundamental frequency or first harmonic. This is about first mode of vibration. What is first mode of vibration? If string vibrates such that only one loop is formed in which only one antinode and two nodes are produced. Number of loops P is equal to 1, and therefore frequency of first mode of vibration 1 divided by 2L root T divided by M. This frequency is called as fundamental frequency or first harmonic. Similarly, second mode. If string vibrates such that two loops are formed in which two antinodes and three nodes produces. जेवढे लूप तेवढे अँटीनोड, त्यापेक्षा एक न जास्त नोड, इज कॉल्ड एज सेकंड मोड ऑफ व्हायब्रेशन. As similar definition. What is second mode of vibration? If string vibrates such that two loops are formed in which two antinodes and three nodes are processed, is called as second mode of vibration, and therefore frequency of second mode of vibration N2 is equal to 2 divided by 2L root T divided by M. This is called as second harmonic, or it is also called as first overtone. ह्याला म्हणतात फर्स्ट ओव्हरटोन, फर्स्ट हार्मोनिक, सेकंड हार्मोनिक. फंडामेंटल फ्रिक्वेन्सी नंतर ओव्हरटोन असतात, म्हणजे हा झाला आपला फर्स्ट ओव्हरटोन. ओके. नाव थर्ड mode of vibration. As similar, if string vibrates such that three loops are formed in which three antinodes and four nodes are processed, is called as third mode of vibration, and therefore frequency of third mode of vibration, that is N3, is equal to 3 divided by 2L root T divided by M. This is called as third harmonic or second overtone, like this. In this way, string vibrates with different modes having a frequency integral multiple of fundamental frequency. म्हणजे सेकंड मोडची फ्रिक्वेन्सी फंडामेंटल फ्रिक्वेन्सी 2 times, थर्ड मोडची फ्रिक्वेन्सी फंडामेंटल फ्रिक्वेन्सी 3 times, like this. Means string vibrates with different modes with the frequency equal to integral multiple of fundamental frequency. Okay. This is about different modes of vibrations. Now, laws of vibrating string. Laws of vibrating string. We know that fundamental frequency of vibrating string is 1 divided by 2L root T divided by M. The fundamental frequency of vibrating string N is equal to 1 divided by 2L root T divided by M. Using this formula, we can develop laws of vibrating string, that are law of length, law of tension, and third one, law of mass per unit length. Basic 3 laws, that are law of length, law of tension, law of mass per unit length. आता law of length. Fundamental frequency of vibrating string is inversely proportional to length of string if tension given to string and mass per unit length are kept constant. म्हणजे जर समजा टेन्शन आणि मास पर युनिट लेंथ कॉन्स्टंट असेल तर फंडामेंटल फ्रिक्वेन्सी इनव्हर्सली प्रोपोर्शनल टू लेंथ. दिस इज कॉल्ड एज लॉ ऑफ लेंथ. व्हॉट इज लॉ ऑफ लेंथ? The fundamental frequency of vibrating string is inversely proportional to length if tension given to string and mass per unit length are kept constant. Second law of tension, root T. The fundamental frequency of vibrating string is directly proportional to square root of tension given to string. Tension चा law. The fundamental frequency of vibrating string is directly proportional to square root of tension given to string if length of string and mass per unit length are kept constant. And third one, about mass per unit length, the fundamental frequency of vibrating string is inversely proportional to square root of mass per unit length. The fundamental frequency of vibrating string is inversely proportional to square root of mass per unit length if length of string and tension given to string are kept constant. लेंथला काय करायचं, टी आणि एम कॉन्स्टंट, टी ला एल आणि एम कॉन्स्टंट आणि एम ला एल आणि टी कॉन्स्टंट, एकाच रिलेशन तयार करायचं. लॉ ऑफ लेंथ, लॉ ऑफ टेन्शन अँड लॉ ऑफ मास पर युनिट लेंथ. आता इथं मास पर युनिट लेंथ म्हणजे टोटल मास डिवायडेड बाय टोटल लेंथ. But we know that density is equal to mass per unit volume. Wire is in the form of cylinder. Wire is in the form of cylinder and therefore volume of cylinder, that is pi r square L. Volume of cylinder, length of wire. Wire is in the form of cylinder and therefore volume of wire pi r square L. And therefore put this value here. Therefore m is equal to m ची value density into pi r square L divided by L. L get cancel and therefore mass per unit length, that is rho into pi r square. च्यापैकी हे तर कॉन्स्टंट आहे. ओके, मग ही व्हॅल्यू समजा आपण इथे घेतली तर मग frequency is inversely proportional to square root of rho pi r square, or which can be written as inversely proportional to r root pi into rho. Thus, fundamental frequency of vibrating string is inversely proportional to radius as well as inversely proportional to square root of linear density of wire. Thus, fundamental frequency is inversely proportional to radius as well as inversely proportional to square root of density of matter of wire. These are about laws of vibrating string. त्यानंतर आणखी तुम्हाला दोन डेफिनेशन सांगतोय. एक म्हणजे फ्री व्हायब्रेशन्स अँड फोर्सफुल व्हायब्रेशन्स. अबाउट फ्री व्हायब्रेशन्स अँड फोर्सफुल व्हायब्रेशन्स. Free vibrations. And forceful vibrations. See, free vibrations are forceful vibrations. Suppose this one as simple pendulum. This is mean equilibrium position. If body is displaced from its mean equilibrium position, and released, then vibrations performed by body are called as free vibrations. म्हणजे जर समजा बॉडीला मीन इक्विलिब्रियम पोझिशन पासून डिस्प्लेस करून रिलीज केलं तर याची ही अशी व्हायब्रेशन्स होतात. ह्याला म्हणतात फ्री व्हायब्रेशन्स. In case of forceful vibrations, suppose this one as simple pendulum. If body is displaced from its mean equilibrium position and release, तर मग ही बॉडी या डायरेक्शनला जाईल. ती हित आल्यानंतर समजा आपण हिथून फोर्स अप्लाय केला, एक्सटर्नल फोर्स अप्लाय केला, तर परत त्याची व्हायब्रेशन्स होतात. मीन्स इफ एक्सटर्नल पिरियडिक फोर्स इज अप्लाइड to this body, then vibrations performed by body are called as force vibrations. Means by using external periodic force, we can produce vibrations. Means vibrations produced by external periodic force are called as force vibrations. Definitions: free vibrations. If body is displaced from its mean equilibrium position and released, then vibrations performed by body are called as free vibrations. And if body is made to vibrate by external periodic force with a frequency different that of natural frequency, then vibrations produced are called as forced vibrations. In free vibrations, amplitude of vibrations goes on decreasing with time. म्हणजे त्याची अँप्लिट्यूड हळूहळू कमी कमी होत जाते. बट इन दिस केस अँप्लिट्यूड ऑफ व्हायब्रेशन्स रिमेन्स कॉन्स्टंट. जोपर्यंत आपण एक्सटर्नल पिरियडिक फोर्स अप्लाय करतो तोपर्यंत त्याची अँप्लिट्यूड तेवढीच राहते. अँप्लिट्यूड रिमेन्स कॉन्स्टंट. इन फ्री व्हायब्रेशन्स अँप्लिट्यूड डिक्रीजेस, but in forced vibrations amplitude remains constant. Frequency of vibrations depends on dimensions, mass, elastic properties and mode of vibration. Mode of vibrations. Frequency of free vibrations. The natural frequency of free vibrations depends upon dimensions of body, mass of body, elastic properties and mode of vibrations. But frequency of forced vibrations depends upon frequency of external force. Frequency of external force only. आपण एक्सटर्नल फोर्सची फ्रिक्वेन्सी किती ठेवतो त्याच्यावरती याची फ्रिक्वेन्सी अवलंबून असते. These are about free vibrations and forced vibrations. ओके, तर या ठिकाणी आपला हा टॉपिक संपत आहे. This is about superposition of waves.